What I wanted to ask you, though, is what I've found, and I'm deciding to kind of open the book and be vulnerable to, my patients and the people who follow me and ask me questions that have influence over their life is, well, I seem to be a little bit of an outlier in terms of the size of the numbers, and maybe that is irrelevant. And I just keep hearing numbers, and I go, well, my number's like 10 times that or 5 times that. Do I need to be, that little voice in the back of my head is going, well,
right.
I don't think this thing called FH is that unique. I mean, I've heard it 1 in 250, 1 in 500, 1 in 100. But that is strange that there's a correlation to how much better I feel on carnivore diet. I mean, compared to keto even. I was only eating like 4 plants for 3 years. And when I gave those up, what my body did was, so I'm kind of laughing. I'm like, well, I'm either heading for disaster or I'm turning into a superhero here. So which one is it?
Right.
And maybe it's neither, but I'd like to think I'm.
Yeah. Okay. So the allopathic community, the medical profession, work by way of setting thresholds in terms of the signals that they use in order to assist them in their differential diagnostic process. They will say this level of cholesterol is okay, right up to and including a given number, and anything above that number is now pathological. There is no grey, there is no black. It's black and it's white. It's okay, or it's pathological. And in the case of elevated cholesterol, the pathological is a tag that's been added there by the pharmaceutical industry that makes the drug that intervenes, that same pharmaceutical industry basically owning the allopathic area of medicine outright, actually, having their fingers in all the pies, having hold of all the strings to control the medical schools and everything. And it becomes a self-sustaining thing in there. What you need to understand is these different sub-fractions of cholesterol. Well, let's approach this from the other way. Why don't you tell me what the difference between LDL cholesterol and HDL cholesterol is?
Well, from my knowledge and what I've been told is LDLs have a lot of different varieties, and it's I've heard the dump truck analogy. It's carrying them, but it's what's in it that's important, not what's carrying them.
Okay.
And then just the common perception, well, HDLs are good now. So higher those are,
good
better.
Cholesterol.
Lower, yes. And the LDLs, of course, they're bad.
They're bad?
Good? Yeah, the bad ones.
Yeah.
Then you realize, well, there's not just LDL. LDL is like a general naming of
all right.
particulates.
So
then I get more confused.
Yes, there's backfilling that we need to do here, obviously. And, even relatively well-educated people are often not in the know on this because it's not their area, it's not really a ball that they've been watching, whatever. Cholesterol is a high molecular weight alcohol, actually. It's waxy in nature, and it serves a multitude of purposes in the human body. Without sufficient cholesterol, you will be dead very, very quickly. I could spend all day going through what the roles of cholesterol in the body are, but there's no point at the moment. I mean, you can go and look all of those things up if you want to. We could spend all day on that. But what's most important to get across here is that there is only one molecule called cholesterol. Go and look in any textbook you like for the molecule cholesterol. It doesn't come in an LDL form or an HDL form. There aren't two different sorts, one with a halo and one with a set of horns, good and bad cholesterol. No, there is only one molecule that is called cholesterol, and it's identical. So how are we partitioning identical molecules of cholesterol out and saying, well, these ones are good and these ones are not good? How does that make any sense? Well, what you need to understand is that the HDL and LDL stand for high density and for low density lipoproteins, respectively. These are a class of lipoprotein which acts as a carrier for cholesterol, triglycerides, other lipids actually as well. Because fat won't dissolve in water and your blood plasma is water-based, you need a carrier for fats that will emulsify those fats in your blood plasma and allow your blood plasma to transport them. That's what the lipoproteins do. And there are a whole bunch of different classes of lipoprotein, as you alluded to, depending on their density, size, which protein it is that is the tag and binder for that particular package. All of these carriers LDL, HDL, IDL, VLDL. They are all protein and lipid-based structures that are encoded for by your DNA. That gene has survived something like at least 4.5 billion years. That's 4,500 million years that those genes have been in effect, pretty much telling the body which lipoproteins to make to carry what lipids around, among other things. Why would your body have a gene that encodes for a thing that will kill you? And why would that survive the natural selection pressures for quite so long?
That's a great question. It would not.
Basically, what it boils down to is that all the lipoproteins, all the subfractions of all the lipoproteins are all in balance in your body according to the genetic instructions of that body. So there is the interaction of that gene set with the environment in which it's placed as to how that will exactly respond. But it will respond in the way that is best conducive to the long-term survival of the individual. So I reckon we could probably just about get out of the way and let our body get on with it, because it's pretty good at it. It knows what it's doing in that regard. You're only deemed to be elevated in cholesterol because you've reached certain thresholds for numbers of standard deviations away from the mean.
And that spectrum of standard deviations away from the mean are that broad. I suppose that's what shocked me, because allopathic doctors would make me think this is not within that normal standard deviation of that mean. This is like way out there. And I mean, I have people with, a fraction of what my numbers just came back, and they're
Okay. The medical profession, the MDs are required to pathologize you over a certain level, which you're well over. They are required to lean on you, to scare you, and they are required to sell you this drug, which will do you no good whatsoever, by the way.
But it will lower LDL in many cases.
Well,
which
sure
is not even, that's like your ice cream analogy. That's like, shutting down the ice cream stand and expecting something to happen.
Yeah. Oh, look, drownings in swimming pools, highly, highly correlated with the release of movies featuring Nicolas Cage. Now, should we ban movies by Nicolas Cage? I think we should.
Yeah.
But not for the reason of preventing drownings, because it will have no effect on drownings.
So here's how I'd love to pivot then. So assuming my body, my genes are not malfunctioning, I have not created any damage to my body that would make a gene go haywire, and it's just that far out of what a normal standard deviation would be compared to most. Are there some things and I want to be specific to the carnivore lifestyle, because that is a lifestyle I am embracing.
Yes.
And I've been happy with. Are there things that can now take that greater than normal standard deviation and create some problems with it? Say, just to speculate, I'll throw a few things and then let you answer. High stress raising cortisol and blood sugar, even though I'm not eating carbohydrate. I'm trying to make it personal because I talk to my clients about this. Maybe caffeine that I don't know about that can be doing something. Maybe not eating the lion style of carnivore, eating too many frequent meals. Are there anything along those ways that can, or is that just all splitting hairs and not worth? Does that make sense what I'm trying to ask? Does it make sense to scrutinize and micromanage and take something that's already working well and try to make it better because I'm afraid of some standard deviation? Or no, 95% good, business as usual?
Well, I guess what I'm alluding to, what I'm trying to get across, is that one's lipid levels are not in and of themselves ever a cause for concern, because elevated lipids do not cause pathology. We're talking about specifically some fraction of the cholesterol in our bloodstream at any given time, which is associated with a given lipoprotein, in fact, being somehow problematic. No, it's a marker too. It's an associate to, and not a very good one anyway. Actually, it's pretty weak. That's why they've originally they said total cholesterol was the best predictor of heart disease. Then they turned out, it looks like the LDL subfraction is a better predictor, although no more causal. And then they said, it's not so much the LDL, actually, it's specifically the protein, the APO100B. That's the issue here. And then they're like, no, it has to be deranged first before it's problematic, because your immune system would have to recognize it as non-native, which means it has to be either glycated, oxidized, or both. So native LDL, no problem whatsoever of any particle size. But then they said, oh no, look, it's the particle size.
Yeah.
So they've tried to drill down more and more and more for a better and better and better predictor retrospectively in large groups of usually aged people that they start with at the outset.
Mm-hmm.
And look what was associated with what, and say what the smallest residuals, the best R squared number on our regression line, once we've adjusted it, in other words, fabricated the results. Okay, that's the one we're going to say, that's the problem because it's the best predictor. No, it's just the best predictor. Here's the thing. You know how I said earlier that cholesterol has a myriad of roles in the body? A lot of people don't realize that one of those roles is in the very integrity of the cell membrane of every single one of the cells in your body. That membrane is 50% cholesterol by weight and volume. If you've got some kind of process that's causing damage to the epithelial cells of your vascular tree, say chronic systemic inflammation, chronic glycation, oxidization, any of those kind of things, there are some invading pathogens that are thought to also be associated with setting off this series of events. Then you need raw material to repair those cells that are damaged. And given that 50% by volume of every one of the membranes of every one of those cells is cholesterol, you better deliver a lot of cholesterol to repair those cells, yeah? How do you get it there? Oh, LDL. That's the transporter for lipids to the cells from the liver.
Every cell in your body.
Right. So if you've got damaged cells in your vascular tree, in your arteries, then your body's going to want to deliver cholesterol to repair that damage.
So can I clarify?
Yeah.
So it sounds like what I'm hearing is whether you are making your allopathic medical lab findings, whether you're right where they say you're healthy, or your standard deviation 1,000,000 where I am up in the stratosphere high compared to that, it doesn't no bearing. What matters is, am I chronically oxidizing, glycolating, damaging the epithelial wall to where my body has to respond to that?
Correct.
Would you say that is really what is the precursor to, say, heart disease, or whatever my allopathic doctors are trying to keep me away from? And maybe they have good intention, but that's really what they should be looking at, is these other factors.
Yes. Heart disease, atherosclerosis, at its root cause, at its etiology, absolutely unequivocally is an inflammatory immune dysfunction, not a metabolic dysfunction, not a lipid dysfunction. No, the underlying root cause is chronic systemic inflammation underpinned by physical mechanical damage to the vascular epithelial beds, as usually moderated most powerfully by one's blood pressure, actually. Hypertension, serious problem for heart disease. There's glycolytic damage, so people that eat a lot of carbohydrates and have that kind of disorder going on are going to have a lot of glycated tissues, and those are going to cause an immune reaction, which is what atherosclerosis is, by the way, an immune reaction. Oxidative damage as a function of some of the pooling or delayed transit time of the blood past the various parts of the high pressure side of the vascular tree that the atherosclerosis are associated with. Could you
repeat that part? That one was
absolutely.
That was like a stagnation where it's not moving through, and those chemicals are sitting.
Yes. Now, the thing that associates with atherosclerotic lesion development more strongly than actually anything else is the transit time of blood past that particular zone in the vascular tree. Now, what's really interesting here is that atherosclerotic lesions develop only in arteries, never in veins. Those arteries and veins carry, it's a pressure issue. And what you get is turbulence caused by bifurcation. So you've got one large vessel that bifurcates into two smaller ones. You've got a Y intersection. That's
like whitewater rafting.
Exactly. So that's where the turbulence is. That's also where you find the atherosclerotic lesions.
Okay.
They're not evenly dispersed. They are very regional, and they are regional to these bifurcations, changes in diameter, areas where the blood can start to eddy around and whirl around, and thus transit that part of the system more slowly thus exerting pressure against the walls, the walls of the epithelial cells lining the vascular tree, thus forcing the blood and its payload of lipoproteins into gap junctions, for example, that are loosened already by an inflammatory response to that injury. So that's a very important aspect is the blood pressure, the
not main, but most common types you alluded to eating carbohydrates. That would obviously be an insulin. I know the word resistance is a good. Is the problem more too much insulin, or is the problem more too much glucose?
The problem is always too much glucose.